Good evening, everyone, and welcome to the virtual public informational meeting for state project number 134-149, replacement of bridge number 04776 in the town of Stafford. This will be a live streamed event on YouTube and through Zoom, and you can also view the project webpage on portal.ct.gov/DOT Stafford-134-149. My name is Mark Burns. I'm the project manager for the local bridge program for the Department of Transportation, and my contact information is as shown. The goals for tonight's meeting are going to be to interact with the project team, explain the federal local bridge program's Design Managed by State or DMS program. We will also take welcoming remarks from the first selectman of the town of Stafford. We will do introductions of the project team, followed by a formal presentation of the design progress. And after, we will have an open forum for questions and answers. If you would like to reach out to us, you can send us an email at dot-flbp@ct.gov, by phone at 860-594-2020, which will be a voicemail, or through the Zoom Q&A chat, which will be available through this presentation. Again, you can view the project webpage at portal.ct.gov/DOT Stafford 134-149. The comment period will be open through December 15th, 2022. I have to read this slide on Title VI, Civil Rights. No person shall, on the basis of race, color, or national origin, be excluded from participation or subject to discrimination in the development of this project. We encourage you to fill out the voluntary post-meeting survey, which is also on the project webpage, and you can also reach any civil rights information at the web address above. A recording of the formal presentation will be posted on YouTube after the live event, which will also include closed captioning, including non-English translation options. The project will be funded through the federal local bridge program in the Design Managed by State or DMS program. And traditionally, under the federal local bridge program, the town would solicit for a designer, and the funding split would be 80% federal with 20% town funds for design, rights of way, and construction. Through the DMS program, design, rights of way, and construction phases are funded with 80% federal and 20% state funds with no cost to the town for any phase of the project. The design, however, will be a full partnership with coordination with the town. The goals when we initiated the DMS program was to provide a streamlined approach to design using all of our DOT resources, aid the towns in keeping their bridges in a state of good repair, decrease typical design time from 5 years plus to 24 to 36 months, to utilize accelerated bridge construction techniques to shorten construction duration, and to increase the number of municipal projects we deliver every construction season. I'll now turn it over to the first selectman of the town of Stafford to provide some opening remarks.
Thanks, Mark. My name is Sal Titus. I'm the first selectman here in Stafford. I'd like to thank everyone for participating in today's public information meeting for the Hydeville Road Bridge. I'd like to thank folks at CHA companies in Connecticut DOT for their hard work into designing and administering this bridge replacement project, as well as our staff in the Department of Public Works for continuing the work on improving our aging infrastructure. Please ensure that you communicate any questions or concerns regarding this project to us. This is your opportunity to get your questions answered. They will forward your questions to the appropriate parties during the comment period. At this time, I'll turn the presentation back over to Mark from Connecticut DOT.
Thank you, Sal. I will also now introduce our project team. From the Department of Transportation, our division chief is Bart Sweeney. Our principal engineer is Derek Lassard. As I said, my name is Mark Burns. To my right is James Barros, project engineer. From the Office of Rights of Way is Zachary Garano. And then from Clough Harbor Associates, or CLE, is Anand Seshadri and Rob Baylor. I'll now quick run through the basic elements of a bridge. As you can see on the slide above, the deck is the traveling surface where pedestrians and vehicles will travel. Adjacent to the deck is the parapet, which protects vehicles and pedestrians from falling over into the hazards below. Below the deck is the bridge superstructure, which carries the vehicular and pedestrian loads through steel beams or concrete beams or different types of beams. The dead load and live load of the bridge is then carried down through the substructure, which will have wing walls and abutments on each side of crossing the water course, and occasionally we'll also have a pier in the middle to help alleviate the full load on both sides. Also, bridges will have a condition, bridges are rated on a condition rating from 9 to 0, 9 being in the best possible condition and 0 being closed to traffic. I will now turn it over to Rob so we can begin the formal presentation. Rob, the floor is yours.
Thanks, Mark. Good evening, everyone. I'm Rob Baylor with CHA. As Mark mentioned, this presentation is in regard to project 134-149. This is for the replacement of bridge number 4776. This bridge carries Hydeville Road over Furnace Brook and is in the town of Stafford. Showing here is the project location map. The bridge is circled there in the center where Hydeville Road crosses Furnace Brook. Hydeville Road runs north to south through the project location, and Furnace Brook runs from east to west. Just to the south of the bridge is East Street or Route 19, and then just to the east of the bridge is Hydeville Pond, which is retained by Hydeville Dam. Next slide. Shown here is some existing bridge data. Looking at the plan, north is oriented to the right. So here the roadway is aligned horizontally on the page. The bridge carries Hydeville Road in the north-south direction, 2 lanes of traffic, 1 lane in each direction. The roadway is 21 feet wide from curb to curb. The average daily traffic across the bridge is about 630 vehicles per day. The speed limit through this area of the road, although it's not posted, is 30 miles an hour, and the 85th percentile speed is 28 miles per hour. And the roadway is classified as urban local roadway. A little bit more information on the existing structure. The bridge was constructed in 1935, so that makes it about 87 years old. The bridge is a 2-span structure, so each span is about 9 feet long with a total structure length of 24 feet. The bridge is comprised of concrete elements. The superstructure is a concrete slab, which is supported by the 2 abutments, one at the north end and one at the south end of the bridge, both constructed of concrete, and also the center pier. All of these substructure elements are founded on concrete footings, and there's also an invert slab along each channel underneath the stream bed. From a hydraulic standpoint, the existing bridge is inadequate. The 25-year storm overtops the roadway. And for this bridge, the design storm is the 100-year storm, which shown in the picture is the dashed line at the top. It's the approximate elevation of the 100-year storm, so well over the roadway. This bridge also, there's no posted weight restrictions. Next slide, James. In regard to the existing conditions of the bridge, based on recent bridge inspection report from August of last year, the bridge, each element of the bridge is rated on the scale of 1 to 9, as Mark mentioned earlier. So the deck is rated in fair condition at a 5. The approach roadway is rated in satisfactory condition. Both the superstructure and the substructure are rated poor, rated at a 4. The channel and channel protection are in satisfactory condition. One other thing I wanted to note, the bridge rail, which is a part of the deck rating, does not meet current safety standards. Let's go through a couple pictures of the existing structure. Starting at the top left is the downstream elevation on the west side of the bridge. Photo to the right of that is the upstream elevation, the east side of the structure. The lower left photo is looking over the bridge to the north. Just to note, on the east side of the bridge is overhead utilities, and there is guide rail along both sides of the road. Photo on the lower right is looking south over the bridge. Wanted to note here that there's a couple of driveways, one on either side of the roadway, that are pretty close to the bridge. Again, starting in the top left, there's a photo of the pavement condition. You can see some cracking and some patching of the existing pavement. Photo to the right of that shows the bridge rail and the concrete curb. The bridge rail post is rusted away from the concrete curb, and there's some concrete deterioration on the curb. The two lower photos show the west fascia and the east fascia of the existing bridge. As you can see, there's significant concrete deterioration on both of these. And this is what's driving the poor condition rating of the superstructure. Starting at the top left again, it's a picture of the underside of span 1. You can see there's some efflorescence there, which is the white spotting. To the right of that is, you can see the south abutment and the pier. So this is also span 1. The footings of both the pier and the abutment are exposed. Photo to the lower left, that's a picture of the south abutment. You can see there's some concrete deterioration there as well, driving the poor condition rating of the substructure. You can also see the southwest stone masonry wing wall there. And then photo to the lower right, that's at the northeast corner. There's a portion of the footing at that abutment where the footing is missing and it's undermined. And then you can also see there's rainwater spilling over the wing wall, indicating there's some poor drainage conditions up above on the roadway. On the top left is a photo of one of the wing walls. That's a typical condition. The wing walls are stone masonry, except for the northwest wing wall, which is built out of reinforced concrete. Photo to the right of that is the Hydeville Dam, just to the east of the bridge. It's about 250 feet to the east. Photo on the lower left and lower right are the upstream and downstream channels, respectively. That brings us to the project purpose and need. So as I mentioned before, the bridge is 87 years old, so it's starting to show its age. It was built in 1935. As I mentioned before, the superstructure and the substructure are rated in poor condition. All the footings are exposed at all the substructure elements, and the north abutment footing is missing and undermined in a portion of it. The existing 21-foot roadway width does not meet either federal or state standards, so we look to improve that. The bridge and the approach rail systems do not meet current safety standards. There's an unknown load rating capacity, and as I mentioned before, there's inadequate hydraulic performance where the 25-year storm overtops the roadway. So this is going to govern the direction of the project, and what we propose here today is a full replacement of the bridge. I also want to note here that despite the deficiencies we've talked about in the past couple slides, the bridge is still safe for the traveling public, and it is routinely inspected by Connecticut DOT. Proposed improvements we'd like to focus on as part of the full bridge replacement we'd like to provide a structure with a 75-year service life and also a structure that requires minimal maintenance. We propose a 24-foot wide roadway realigned slightly to the west, which I'll get into a little bit later. We'd also propose a crash-tested open bridge rail system along both sides of the roadway across the bridge, improve hydraulic performance without having any floodway impacts. This bridge is located in a FEMA floodplain zone. We'd also like to accomplish bridge replacement quickly. That way community impacts are minimized, and then also improve aesthetics by using concrete form liner facing and bridge rails. So you can see in the photos below, both photos are showing a bridge rail, which will be similar to what we're proposing for this bridge, and also concrete facing simulating stone form liner, which we would propose at the exposed concrete surfaces. The bridge that we are proposing tonight is a twin box culvert. So this here is the plan of the bridge. Again, north is to the right, so the roadway is shown there in yellow horizontally across the page. The bridge is shown there in orange in the center. At all four corners of the bridge, we're proposing wing walls to support the approach roadways. The stream there runs from the bottom of the page to the top, from east to west. The bridge we're proposing is, again, 24-foot wide curb to curb width. And it's a twin box culvert. So the two box culverts will have a span length of 16 feet each. Slide. The twin box culvert elevation view is shown on this slide. As I mentioned before, the twin culverts will have 16 feet clear span and a 10-foot rise. On top of the bottom invert of the box culvert will be natural stream bed material to facilitate fisheries. And then above the bridge would be the open bridge rail system that we previously mentioned. And then at the four corners of the bridge on the two sides shown here, you can see the concrete wing walls. Those are shown in gray there with the simulated stone form liner. As shown here, the proposed bridge, you can see the storm elevations. The 50-year storm will be passed through this structure. As I mentioned before, the existing bridge doesn't pass the 25 years, so this is a significant hydraulic improvement. We're achieving that by proposing a bridge with a shallow superstructure depth and increasing the span length. This slide shows a section view of the bridge. So basically taking a cut through the bridge and then looking along the roadway. The curb to curb width that we're proposing is 24 feet. The bridge rail will be installed along both sides of the roadway for protection of traffic and pedestrians. And then below that is the actual box culvert, twin box culverts that we're proposing. We're proposing those as precast. So those will be set in place by a crane to reduce the duration of construction. And then those will be constructed on top of cutoff walls and return walls, shown in gray there. Here we're showing the proposed roadway plan. So in the plan here, north is to the right again. So the roadway runs horizontal and the stream runs from the bottom of the page to the top. The proposed roadway is proposed to be fully reconstructed within the limits shown in yellow. So that's about 360 feet along Hydeville Road, and then about 220 feet along East Street, the portion of intersection that runs off to the west. We're proposing to realign the roadway slightly to the west, about 5 feet. That will improve the horizontal alignment of the roadway and also move the roadway a little further away from the town right-of-way and private properties to reduce impacts there. On the north side of the bridge, just to the right of the bridge in this plan, we're proposing a drainage system to help mitigate some of the existing drainage issues at the bridge. For the proposed roadway profile, we are proposing to maintain approximately the existing profile. We'll just be smoothing out what's there now. As I mentioned before, the existing storm, the 25-year storm existing doesn't pass, it overtops the roadway. And in the proposed bridge, the 50-year storm will pass underneath the structure without overtopping. During construction, we are proposing a bridge closer and a roadway detour. That detour is shown here on the screen. North is up in this plan. So the detour would travel along Upper Road to the west and then connect in with Leonard Road, go south, and then back east on East Street or Route 19 back to the project location. The detour is about 2.4 miles long. It's about a 6-minute detour. The reason we want to do this is it creates a safe work zone for the contractor and the residents, and then it also will help shorten the construction duration. Looking at environmental and utility impacts. So starting with utilities, as I mentioned before, there's overhead utilities on the east side of the bridge, as shown in the picture. Those will have to be temporarily relocated further to the east. And then after construction, they'll be relocated back to their approximate location. As I mentioned before, on the north side of the bridge, we'll be adding a drainage system. And then there's an existing drainage system on the south side that we'll be modifying. As far as environmental impacts, we're anticipating some tree clearing along both sides of the roadway. And there will be temporary and permanent wetland and watercourse impacts due to the bridge replacement. The permits we're anticipating at this point are a Town of Stafford inland wetland permit, a flood management certification, an Army Corps pre-construction notification, and a Connecticut Deep pre-construction notification. I'd like to take a little bit of time to talk about rights-of-way impacts. As shown in the plan here, the roadway is horizontal on the sheet, so north is to the right again. The plan shows the rights-of-way lines in red, so that's the town right-of-way, and then the property lines as well. So there are only property impacts on the east side of the road. And I'm going to walk through those quickly here, starting with the property at the southeast corner. There will be a small portion of the driveway that will need a right to reconstruct. Moving to the right of that is the property that contains the brook. There will be a small temporary construction easement and a small area that will need to be regraded to support the roadway. And then the property to the northeast of the bridge, that one will have a portion of the driveways that need to be reconstructed. There will also be a small temporary construction easement and a small portion that needs to be regraded to support the roadway. As far as temporary construction easements go, for this project, those are small in nature, and the reason we need those would be for providing the contractor access to the project area, and giving him the space to work. this point, I am going to turn it over to Zach from Connecticut DOT Rights of Way to go through the acquisition process.
Thanks, Rob. Like Rob said, my name is Zachary Garino. I'm the project coordinator with the department's Division of Rights of Way. Our office is responsible for acquiring the property rights needed for transportation projects. The proposed project design requires acquisition of property rights, so I'd like to give a brief overview of the department's right-of-way acquisition process. Please keep in mind that the specific impacts are still being finalized and may change as the design progresses. Any required property rights will be acquired in accordance with Connecticut General Statutes sections 13A 73 and 13A 98E. When there is federal money used in any aspect of a project, the department must adhere to the Uniform Act. Change the slide. Once the design has progressed to the point where we are ready to begin the acquisition process, each affected property owner will receive a formal letter of intent to acquire from our office along with a property map which depicts the exact property rights to be acquired. At that point, our office will determine the fair market value of those property rights and use that value to establish an offer of just compensation. That offer will be sent out to the property owner in writing, and a right-of-way agent will be available to meet with the property owner and explain the project, go over the specific impact to their property, and explain the state's offer. The property owner will have a reasonable time, typically 30 days, to consider the state's offer and enter negotiations. When an agreement is reached, the department will prepare all the necessary paperwork to record the deed and property map on the town land records. However, and if agreement cannot be reached, in order to keep on schedule, the department may acquire the necessary property rights through its power of eminent domain. In that event, the state files a notice of condemnation in the Superior Court, along with a monetary deposit in the amount of the state's offer. The owner would have 6 months from that date to file an appeal if they felt that the state's offer was inadequate. Whether or not the owner chooses to appeal, the money deposited in the court is available to be withdrawn by the owner. It's important to note that the state only acquires property rights that are needed for the project. And if there's any questions specifically related to the right-of-way process, I'd be happy to address them after the presentation. Thank you. Hand it back to Rob.
Thanks, Zach. One last slide here for me. I'd like to just quick go through the project schedule and the cost. So at this point, we are planning for construction to start in the spring of 2025. And the construction duration will be approximately 8 months. The construction cost is about 2.8 million. And as Mark mentioned early on in the presentation, the project will be covered by 80% federal funds and 20% state funds. So there's no cost to the town here. Keep in mind, this is a preliminary cost and schedule, and these are subject to change based on final design and permit approvals. And I will turn it back to Mark at this point to facilitate question and answers.
Excellent. Thank you, Rob. Thank you, Zach, for the presentation. That, ladies and gentlemen, concludes our formal presentation. So we'll now open up it to the question and answer portion. Again, you can reach us by email, by phone, or through the Zoom Q&A. Thank you. Again, that project email is dot-flbp@ct.gov. We have a question from Daniel Carr from the Stafford Fire Department. In the current state of the bridge, is there any concern with weights of vehicles crossing over? CHA, if you could answer that question.
Yeah, this is Rob from CHA. At this point, there is not any concerns with vehicles crossing over the bridge. If at any point that does become a concern, then we will bring that up to the town. But again, at this point, the public is free to travel across this bridge.
Great, thank you, Rob.
Mark, I'll just add here that since a representative from the fire department is here tonight, we will be coordinating with the town as far as schedule for the start of construction. And that way the town is well aware of when the bridge closure will be in effect during construction, and then emergency services will be able to plan around that.
It's a good point, Rob. Thanks for bringing that up. Again, thank you to those who attended. We're still taking questions for a few more minutes. All right, we're gonna give this a couple more minutes. If you have any other questions, we can answer them now during live Q&A, but if you have questions that come up later, you can either reach us by phone or by email. Yes, thank you. I see that you have another comment. We will, yes. Please feel free to reach out to us. And if you have any questions related to rights of way, Zach will be able to answer those to you as well, along with his team in the Office of Rights of Way. do you have a number for Zach? Zach, if you would like to put your contact information, either your office line or your email.
Yeah. Can type the answer there. So,
Yes, perfect.
I just replied to the comment. Should be there now. And I typed it on there.
Great. Thank you, Zach.
You're welcome.
You're welcome. We'll give this another minute or two. Okay, I think at this point, we will conclude the live question and answer session. We appreciate all of you attending and asking the questions. If, again, you could please go to the project webpage at portal.ct.gov/DOT Stafford 134-149. And if you would please fill out the survey, which is also put into the chat as well. Thank you very much and have a pleasant evening.